It says quantitative SAT scores have a mean. So for the SAT, the mean is 500, it says, and the standard deviation is 100. For the ACT, it says the mean is 21, and the standard deviation is 5. Alright, and it says, assuming both types of scores have distributions that are unimodal and symmetric, which one is more unusual? Okay, so both are unimodal and symmetric. Okay, which means the empirical rule can apply and we can use z-scores. Okay, z-scores to compare things that are unusual. So in this case, we want to know we have an SAT score of 750 or an ACT score of 28. All right, so let's ask, what is the z-score that corresponds to this SAT score? So a z-score is the number of standard deviations we are above or below the mean. So how many standard deviations above the mean are we? So 750 is 250 points above the mean. So I do, to get my z-score, I'm going to take 750, subtract off the mean, and I'm going to divide by how large each standard deviation is. So 750 is 250 points above the mean. Each standard deviation is 100 points. So a score of 750 is 2.5 standard deviations above the mean. Over here, my ACT score is 28. So my z-score here is going to be 28. 28 is 7 points above the mean. Okay, so I do 28 minus 21, and each standard deviation is 5 points. So here my z-score is 7 divided by 5. 28 is 7 points above the mean. Each standard deviation is 5. So that means we are 1.4 standard deviations above the mean. So the SAT score is 2.5 standard deviations above the mean. Here, the ACT score is 1.4 standard deviations above the mean. Okay, the mean or average ACT score is 21. The average SAT score is 500. So here, our SAT score is more unusual. Okay, so in fact, 95% for unimodal and symmetric distributions, 95% of data is within 2 standard deviations of the mean, and our SAT score is 2.5 standard deviations away from the mean. So it's in that less than 5% of the people have SAT scores of 750. Okay, so it's quite unusual and very impressive in this case.